Welcome to KET Academy. In this video, we are going to be answering GCE 2020 paper 2 question 3. Okay, question 3 sub 1 reads: draw the truth table for each of the prepositions P implies cure and not P or cure, and show that they are identical. 6 marks. Sub 2: given that sine inverse of x is equal to alpha and cos inverse of x is equal to beta, show that sine alpha plus beta is 1. 4 marks. Question 3 sub 1 says that we should draw the truth table for the two prepositions P implies cure and not P or cure, and show that they are identical. Now, to show that two prepositions are identical, it means that they have the same truth values. And to show this, we simply need to draw their truth tables and compare the preposition P implies cure and not P or cure. If the truth values are the same, therefore they are equivalent, and from there we conclude, and that will be all. So if you draw your truth table, you're going to have something like this. And notice that I've repeated the preposition cure, but this time around in a different position, but with the same truth values. Now, this is particularly important because once we are dealing with prepositions such as implication, then the result of our proposition will solely depend on the initial statement, which are P and cure. So if the positions are swapped, we are going to get different results. So it's always advisable to repeat this initial statement so that we shouldn't get confused with their positions. If we negate this statement P, we're going to get false here. We're going to get false here. We're going to get true here. We're going to get true there. Now, P implies cure. For implication, P implies cure is only false when the first statement is true and the second statement is false. Otherwise, it is true. So what you need to know is just to memorize or to understand the prepositions with their conditions. So I'm going to make a separate video on logic that I'm going to take you guys through the various prepositions and their conditions, and what you need to know is just to memorize and understand them, so that whenever a question like this is brought, you just simply need to draw and apply those conditions. So P implies cure, we are now dealing with the preposition P, which will be this implies cure. We're dealing with this preposition. Now this and these two prepositions. Now the first statement is true and the second statement is true, therefore P implies cure will give us true. Therefore P implies cure will give us true here. True, false will give us false, as I said earlier, because of the condition. And false true will give us true, and false will give us true. Now with the preposition not P or cure. Okay, now we're with the preposition not P or cure. So we are with this. So, and we know that the condition for the preposition disjunction, which is this or, is that it is always true unless when the two prepositions are false. So if we draw our truth values, we are going to have false will give us true, and the false will give us false. True will give us true, and the true false will give us true. And the true false will give us true. Now, taking a look at these two prepositions, taking a look at this, what do we notice? We notice that the truth values are the same. So if these truth values are the same, therefore the preposition P implies cure and not P or cure are similar. So we conclude from there. So we conclude by simply saying P implies occur is equivalent to not be occur, because in the other textbooks you're going to be familiar with this sign, the equivalent sign, or they might even come and ask that show that P implied square is equivalent to not P occur. So you're going to follow the same steps. So after doing that, so sub 2 says that sine inverse of x is equal to alpha and cos inverse of x is equal to beta. So we all know that if sine inverse of x is equal to alpha, this implies that x will be equal to sine alpha. X will be equal to sine alpha. And now if cos inverse of x is equal to beta, this simply implies that x will be equal to cos beta or cos beta. Now we have seen that the x is equal to x, therefore sine alpha is equal to cos beta. We are going to name this our equation 1. So from this equation 1, it also implies that sine squared alpha is equal to cos squared beta. Now this is our equation 2. I'm going to explain why I did this in the course of the video. So now we are required to show that sine the alpha plus beta is equal to 1. So this is like a trigonometric proof, and we know that in trigonometry, or to prove in trigonometry, what we simply need to do is we take either the left hand side, we show that it's equal to the right hand side, or we take the right hand side and show that it's equal to the left hand side. So in this case, we are going to take this and show that it is equal to 1. Now from our compound gradient, we know that sine alpha plus beta is the same as sine alpha cos beta plus cos alpha sine beta. So what we are required to do here is either to convert all of our angles to either alpha and simplify a result, or convert all of our angles to either beta and simplify a result. Either ways, the answers are going to be the same using the initial conditions given to us. So we know that from equation 1, we see that sine alpha is equal to cos beta. So anywhere I see cos beta, I should either replace it with sine alpha. So we are going to have sine alpha plus, now cos, because I've decided to change all my angles to alpha. Now sine beta, there's no sine beta here, but what do we know? We know that from the identity, sine squared beta plus cos squared beta equal to 1. We can make sine beta subject. So sine beta will be 1 minus cos squared beta, all that squared. So from this identity we have made sin beta subject. We simply replace it in the position of sin beta. So we're going to have in this position now, we're going to have the square root of 1 minus cos squared beta. Now why do I do this? Because I already have from equation 1 we see that cos beta is sin alpha, and equation 2 says that cos squared beta is sin squared alpha. So anywhere I will see cos squared beta, I simply replace it with sin squared alpha. So that is the main reason I squared this equation 2, so that I can replace it here. So doing that, we are going to have sin alpha times sin alpha here. Sin alpha times sin alpha will give us sin squared alpha plus, now we have cos alpha, the square root of 1 minus cos beta. I'm going to replace it with sin squared alpha from equation 2. Sin squared alpha from equation 2. So we know that from this identity, sin squared alpha plus cos squared alpha equal to 1. If we send sin squared alpha the other way, we are going to get cos squared alpha to be equal to 1 minus sin squared alpha. So anywhere I see 1 minus sin squared alpha, anywhere I see 1 minus sin squared alpha, I simply replace it with cos squared alpha, so that my final conclusion will be that sin, so coming this way, sin squared alpha plus cos alpha plus cos alpha. Now the square root of, instead of writing 1 minus sin squared alpha, I'm going to write cos squared alpha. Now the square root of x squared, from indices and logarithm, we know that the square root of x squared is simply the absolute value of x, which is simply x. Now if we apply this here, we are going to get that we have sin squared alpha plus cos alpha times the absolute value of cos alpha. But the absolute value of cos alpha will be cos alpha, since cos is an even function. Therefore, we are going to have sin squared alpha plus cos alpha times cos alpha. So further simplify our answers, we're going to see that this will be sin squared alpha plus cos squared alpha. So looking back at equation star and changing the angle from beta to alpha, what are we going to notice? Even from equation double star, this equation, looking at this equation, sin squared alpha plus cos squared alpha is 1. So this will simply be equivalent to 1. So that's our proof. Okay guys, thank you very much for watching my video till the end. Please, if you have any question, you can leave it in the comment section below, and you can also tell me any mistake I did or any correction you would like me to make in my video. If it is my voice or you're not getting me, or if you're not seeing what I'm writing, you can simply put it in the comment section. There I will be very happy to answer anybody. Please, if you know that this video helped you in one way or the other, just give me a like to support me, and share to your friends who are writing your exams or those who are interested in knowing mathematics. Okay, I'll be making more videos, so please subscribe to my channel so that whenever I make those videos, you'll be notified that I've uploaded a video and you'll be able to watch and learn. Thank you for watching again, and stay blessed.